So to continue, we still are in the piston type of engine. We want to look into the continuous combustion engine, right? We still in under 1.2.1.2, continuous combustion engine. So in the continuous combustion engine, okay, normally we have turbine shaft engine, incorporating turboprop, turbo shaft, as well as the prop fan engine. So these kind of engine are distinguished by the presence of rotating elements. And normally we call it as the turbo machinery, or turbo machines. These module or sub-modules encompass or include the fans component, the compressor, the turbine, as well as the propeller or prop fans. Okay, we will go into one by one. Let us look into the first one, turboprop. What is turboprop? Turboprop engine are utilized to power both civilian as well as the military transport aircraft, which normally cruise speed below 700 kilometer or 450 miles per hour, right? And this type of engine, the turboprop engine, consists of a gas generator. It also encompass of a compressor, which has also combustion chamber and turbine, along with a propeller, right? So imagine an engine which has propeller in front. Okay, it is a turboprop engine. So the turbine serve the dual purpose. One is to drive the compressor, because the propeller itself will be connected to the compressor, as well as drive the propeller. And the turbine serves a dual purpose, because the turbine is connected to the compressor and the turbine also connected to the propeller. Right. So due to the optimal spinning speed of gas turbine, which is normally very high, a turboprop will incorporate a gearbox, because it has to reduce the shaft speed to prevent the propeller tips from reaching supersonic speed, and you do not want that to happen. Okay, and alternative design normally involve the addition of a second turbine to the turboprop. Okay, second turbine is connected to the turboprop engine, which exclusively drives the propeller either directly or through a gearbox. Okay, in this configuration, the first turbine is dedicated to drive the compressor, which allows it to rotate freely. We will look at a small schematic diagram later on that shows the arrangement, which is referred to a free or power turbine, while the other turbine is designated as the compressor turbine. Okay, so modern turboprop engine normally generates around from both the propeller and the exhaust jet stream, which with approximately 10 to 20% of the thrust. Okay, it is contributing the turboprop engine from the propeller and exhaust stream, probably around 10 to 20% of the thrust produced by the jet stream. Consequently, some individuals classify turboprop as jet engine or reaction engine. Okay, so this is just the picture of a single shaft. The top figure depicts or show a single shafted design with propeller. So you can see the propeller in front here. There is a gearbox to reduce the speed, right? So that it can be connected to the shaft, that is interlinked with the compressor stage. The combustion chamber is that orange color, and then the turbine stage before it goes to the exhaust. Compared to the free turbine, um, this particular figure shows the free turbine, where you can see that the propeller itself, okay, connected directly to the free turbine, and the turbine is not connected to the compressor. Okay, and so it is, that's why it is called the free turbine. It is connected directly to the propeller. Right. The turboprop engine are exemplified by models, the famous Rolls-Royce T56, and then which being utilized in P3 Orion or C130 Hercules. Maybe you hear the name Hercules more than C130, right? And another illustration of the Rolls-Royce AE2100 engine, having a power range of 3,000 to 6,000 shaft horsepower, and is also installed in C27 J Spartan, the Mewa US-1A Kai aircraft. Okay, at the same time, the modern Airbus military A400M also uses a turboprop engine, Rolls-Royce TP400D6 engine. Right. Among the earliest turboprop engine, such as the Pratt and Whitney T34 powered various type of aircraft, including the B-17, KC-97J, or Douglas C-133A Cargo Master. Okay, normally it is for bomber, for cargo transport, and so on. The PT6 turboprop engine, which manufactured by Pratt and Whitney Canada, stand as the most widely chosen power plant in its class. So it has a very high horsepower over there, and has been selected by for more than 130 different applications. Normally being used as a business type of aircraft, commuter type of aircraft, trainer, as well as utility aircraft. Right? And then General Electric, GE also contributes to the field in the turboprop design with its CT7 turboprop engine. Okay, it is powering Saab 340 or IPTN. This is a industri pesawat terbang Nusantara, the Indonesian type of aircraft, CN235. All right. Then we move to the turbo shaft. Okay, just now turboprop. I would like you to focus what is the main difference between the two, turbo shaft and then turboprop. Just the turbo shaft engine primarily utilized in helicopter as well as auxiliary power unit. Okay, so the design of a turbo shaft engine closely resembles that of a turboprop. It looks like a turboprop, but with a notable distinction. There is a difference between it. Okay, the engine support the propeller and the entire assembly attached to airplane. Okay, this is in turboprop. For turboprop type of aircraft engine, the engine will support the propeller, the entire assembly attached to the airframe. Whereby, for a turbo shaft configuration, the engine does not directly provide physical support to the helicopter's rotor. Okay, instead, the rotor is linked to a transmission. It's not linked directly, but it has a transmission which is bolted to the airframe. Okay, that's a huge difference between a turboprop and a turbo shaft, where turbo shaft engine supplies power to the transmission through a rotating shaft. Okay, if you look here, typical Seahawk helicopter, and it's being powered by GET 700 turboshaft engine. Okay, while some view the difference as subtle, certain aircraft manufacturer produce both turboprop and turboshaft engine based on a common design. So, but normally it has a very distinctive difference between a turboshaft as well as the turboprop type of engine. Additional instances of turboshaft engine include Rolls-Royce RTM 322, right? And then it is powering the Augusta Westland, namely Apache type of aircraft, helicopter, the Rolls-Royce Genome, and being used to power the Augusta Westland Sea King, as well as the Kawasaki or Boeing Vertol 107. Okay, so the Augusta Westland Superlink, the Malaysian Royal Air Force are using, the Navy are using this type of aircraft, Augusta Westland Superlink. That is a type of example of a turboshaft type of engine. GE T700, okay, that historically significant turboshaft engine. It propels the Marine Corps or nicknamed Super Cobra, crafted by Bell manufacturer, military Sikorsky H60 and international variant of the Sikorsky 770, also a type of example of a turboshaft engine. So in the commercial realm, in commercial business, the CT7, a derivative of T700, which also serve as the power source for Bell 214 ST, Sikorsky 7 S70C, as well as Westland WS70. All right, so that's being used in the historical background of the turboshaft type of aircraft, type of engine. Next, we look at the prop fan. What is a prop fan? Also known as unducted fan, because the fan is outside the engine. Okay, you will be interesting to see the picture of the prop fan. In the former Soviet Union, a turboprop fan represent a modified turbofan configuration where the fan is positioned externally to the engine nozzle, compared to the internally to the engine nozzle. Okay, it is sits on the same axis as the compressor blade. A prop fan are alternatively referred to as ultra bypass engine. So ultra bypass. So you have bypass engine. This one is ultra high bypass, meaning that the flow of air majority will go external to the engine instead of the core of the engine. Okay, and more recently we call it as a open rotor jet engine. So this design aims to combine the speed and performance attributes of a turbofan with the fuel efficient of a turboprop, right? The prop fan concept emerged as an effort to achieve superior fuel efficiency. That's the main alternative, main aim, fuel efficient compared to contemporary turbofan. Okay, albeit with a trade-off or in increased noise level. Because of the location of the fan itself, it will generate a lot of noise. Okay, right? So this is what the one that I said just now. You can see that the fans are located to the rear of the engine, is external instead of internal to the engine nacelle, right? This is creating a lot of noise. So General Electric GE36 unducted fan. Okay, following to that, McDonnell Douglas also undertook the development of a proof of concept aircraft by modifying its own MD-80. So this is involved the removal of JT8D turbofan engine, okay, then being replaced by GE36, a prop fan type of engine. Okay, there are test flight in USA, which concluded in 1988, demonstrated a noteworthy 30% reduction in fuel consumption. It is a fairly reduction of fuel compared to the turbofan powered MD-80. So compared to MD-80, GE36 has a lower fuel consumption with minimal level of exterior and interior noise vibration. All right. So despite this promising result, the program was shelved by McDonnell Douglas in the subsequent years, influenced by a decline in jet fuel price and evolving marketing priorities. All right. In the 80s, Ellison collaborated with Pratt and Whitney to develop a new type of prop fan kind of engine. They have a successful flight test conducted by McDonnell Douglas. However, it is sad to say that this project materialized into commercial application primarily due to concern because of the excessive cabin noise. Because passenger doesn't want very noisy cabin compared to turbofan and the prevailing low price of fuel. All right. So this is another example of a prop fan where you can see that this beautiful type of fan. This is Ivshenko Progress D27 prop fan developed by the Soviet Union, USSR, features a prop fan blades positioned at the front of the engine in a tractor configuration, as illustrated here. The prop fan of D27 were utilized to propel the Antonov AN-70. This three-shaft prop fan engine has a propeller diameter of 4.5 meters and a dry weight of 1,650 kilogram. So it gas generator comprise an axial low pressure compressor, a mixed flow high pressure compressor, an annular combustion chamber, a single stage high pressure turbine, and a single stage low pressure turbine. So this is the arrangement of the components for this prop fan D27 engine. Okay. Another type of example, SB27. This is a contra-rotating prop fan which is driven by four-stage turbine through a shaft connected to a planetary reduction gear. Given the current high price of jet fuel and the increasing emphasis on enhancing engine airframe efficiency to reduce emission, okay, there is a renewed interest in the prop fan concept for potential use of Boeing 787 and the Airbus A350 XWB aircraft. For example, Airbus has patented aircraft design featuring twin rear-mounted counter-rotating prop fans. Okay, right. Now we want to move into reaction engine. Okay, before we move to uh, other type of engine, this reaction engine, also known, also a category of air-throttled, where aero-thermodynamic duct or turbine type. Okay, we will look into uh, explanation on a ramjet, a pulse jet, scramjet, as well as the turbojet, turbofan, turbo ramjet, turbo rocket, and advanced ducted fan engine. Right. In essence, all reaction engine generate propulsive force. And later on, for today, we are going to just to expose to you what are the type of engine. We will later look into the calculation. We are not going to do calculation today. We are going just to expose to you these are the type of engine. It generate propulsive force and as a reaction to the jet exhaust gases. Common to all reaction type, there are three crucial modules. An entry duct, normally we call it as an inlet or intake, and then you have a combustion chamber where we put energy to the air that coming into the engine, as well as then we have the exhaust nozzle where we propel and we accelerate the air that having enough energy from the combustion chamber go through the exhaust nozzle. So this exhaust nozzle will accelerate the air or gases to speeds greater than the flight speed. Okay, that's why it will generate thrust, which then propel the aircraft forward. Okay, the attribute group comprises engine. We want to look at ramjet, pulse jet, and scramjet, which lack significant rotating elements or turbo machinery. Okay, let us look into the first one, which is the pulse jet, which operate intermittently and has seen limited application. All right, and then in ramjet engine, the compression of air by ram action becomes adequate to eliminate the necessity for mechanical compression, and ramjet is particularly suitable for supersonic flight speed when the flight speed is exceptionally high, requiring supersonic fuel combustion. The ramjet is referred to as a scramjet. Okay, let us go into one by one. The ramjet. What is ramjet? Ramjet, sometimes colloquially known as a stovepipe jet, right? Because it represents a type of jet engine that utilizes the forward motion of the engine to admit and compress incoming air, dispensing with the need for a rotary compressor. Okay, it doesn't need a compressor stage. Ramjet are incapable of generating thrust at zero airspeed. Okay, that's why it requires the aircraft to be using other type of propulsion system before you can ignite or start the ramjet type of engine. Okay, so that's why it's very difficult, or it cannot be done to propel an aircraft from standstill, from the uh, to start the engine, to start the aircraft, to move the aircraft. It is impossible. Yeah, but once it's already moving, then you can start the ramjet. And the ramjet comprise three essential modules. You have the inlet, you have the burner, as well as the nozzle. Okay, it looks like this. There are two type of ramjet. One is the uh, liquid fuel, as well as the other one is the solid fuel ramjet. And ramjet engine can operate at either subsonic or supersonic speed. So you can see here Lorentz ramjet or subsonic type of ramjet, where you have the air intake, you have the air being flown into the what we call is the combustion chamber. We have the fuel supply, and then we burn the air at a high speed, and then we have the propelling nozzle. As simple as that. You do not have the turbine, you do not have the compressor. Okay, similarly here, supersonic ramjet. Okay, you have the inlet intake, you have the diffuser to slow down the flow, and then you have fuel injection, you have the combustion process occurring here, and then the convergent divergent nozzle type of configuration, right? For the ramjet, subsonic ramjet do not require a sophisticated inlet. You can just use a normal subsonic type of inlet, typically utilizing a simple hole. In contrast, supersonic ramjet decelerate supersonic flow to subsonic speed, right? You cannot burn the fuel at supersonic flow. That's why you need to reduce by having a diffuser in the supersonic ramjet configuration. Okay, and it will go through the inlet through one or more oblique shock wave, terminated by a strong normal shock. Okay, normally in your compressible flow aerodynamics, you will learn more about the effect of this oblique shock wave and normal shock. Okay, consequently, the air achieves subsonic velocities upon entering the combustion chamber. Okay, and the combustor enhances the compressed air by introducing heat and mass through the combustion of fuel. So within the combustion chamber, flame holders prevents the flame from extinguish. Okay, we prevent it from flame off. A ramjet combustor can operate safely at a stoichiometric fuel to air ratio, indicating a combustion exit stagnation temperature on the order of 2400 degrees Kelvin for kerosene type of fuel, right? The resulting combustion products exit the combustion chamber and undergo re-acceleration through nozzle, reaching a supersonic velocity via convergent divergent nozzle, like I shown just now. And the supersonic ramjet speed optimally at around Mach 3 and can operate at least at Mach 5. The next one is pulse engine. Okay, pulse engine, often referred to a pulse jet, is a straightforward form of jet engine characterized by intermittent combustion pulse. Unlike ramjet, which employ continuous combustion, the pulse jet utilizes intermittent combustion, right? It's not continuous. So these engines are distinctive due to the ability of to operate statically with minimal or no moving parts, no turbo machinery. Okay, they are known to be simple, cost effective, and providing favorable balance between cost and the function. A pulse jet engine can run on various petroleum grades, okay, thanks to the ignition of shuttle system. However, their noise are deemed unacceptable because it's very noisy for pulse jet. Despite this drawback, they boast both high efficient and remarkably high thrust to weight ratio, compared to other jet engine. Puff jet can be manufactured in various sizes, ranging from a few pounds to several pounds, thousand pounds of thrust. Okay, this is just a typical arrangement of puff jet operation. So there are two types. One is the type of using valve. There is a shutter valve. Okay, shutter valve. This is the shutter valve, where the other type is without the valve. We call it as the valveless type of puff jet engine. So for the valve type engine, a mechanically one-way valve, typically a straightforward leaf spring type of shutter is employed. There's a movement where the valve is open, a new air charge will enter. And the air mixed with the fuel, leading to an explosion that subsequently close the valve, and this closure force the hot air gas to exit solely through the tailpipe. We will just go through the tailpipe and creating space for fresh air and additional fuel to enter through the intake. Okay, this you can refer back to figure A just now. And the super heated exhaust gas then exited through an acoustically resonant exhaust pipe. Compared to the valveless, there's no valve involved, no moving parts, rely solely on their geometry configuration, as shown in figure B just now. And this engine expel exhaust through both the intake and the exhaust, with the objective of directing the majority of the exhaust through the longer tailpipe for enhanced propulsion efficiency. All right. The combustion process generate two shock wave, fronts, one traveling down the upper long tube and the other down the shorter lower tube. Right? So through careful tuning, a resonating combustion process is achieved and resulting in significant thrust. However, this engine exhibit high fuel consumption and their noise level are unacceptable. Okay. Next is a pulse detonation engine. We call it as a PDE, and represent a novel approach to non-continuous jet engine, right? Offering potential superior of fuel efficient as well as especially at very high speed for PDE type of engine. We have Pratt& and Whitney and GE actively having PDE research program. Okay. Then we have scramjet engine. It's also an extension of the ramjet. We call it as a scramjet because it operate at a supersonic combustion ramjet, right? So instead of Mach number 3 to 5, it can go maximum of Mach 17, right? So this is just a write up about what is the scramjet being used. There are many research being conducted at hypersonic vehicles. Right, this is just a typical scramjet engine configuration. You can see that there's a vehicle bow shock and flow from Mach 4 to Mach 15, very high speed. We reduce the speed by going through this shock boundary layer, shock boundary layers interaction before the fuel being injected. So you can have the again, there's no rotating machinery. Okay, there's no compressor, there's no turbine required for this kind of scramjet type of engine. Okay. So the propulsion system comprises 5 major components. You have the inlet, isolator, combustor, internal nozzle, and fuel supply system, right? So it looks very neat, but it's actually very difficult to control in terms of the shock formation. Okay. Both hydrocarbon and hydrogen has already been used for the fuel for scramjet, but is still in the experimental stage. Okay, so that's why we can have the experimental aircraft, NASA X-43, Boeing X-51, and the rest. Next one is turbine engine. Okay, turbine engine. This is the one that we are going to focus more. Turbojet, turbofan, and then of course we have turbo ramjet, turbo rocket, and advanced ducted fuel engine. For the turbojet, it goes back in the invention of Sir Frank Whittle in the UK, as well as the von Ohain in Germany in the 1930s. And this is just prior to the World War One. After World War One, many modern that's where the turbojet engine being developed heavily. So it incorporates one or more compressor to intake and compress air, and combustion section that adds and ignite fuel, one or more turbine extracting power from the expanding exhaust gas to drive compressors and provide power to aircraft system, and the exhaust nozzle accelerating the exhaust for thrust creation. Okay, so a typical turbojet engine, you have the intake. This is axial compressor. Okay, you have intake. You have the series of compressor, low pressure compressor, high pressure compressor. You have the combustion chamber. Okay, you have the turbine, high pressure turbine, low pressure turbine, and then the nozzle. Similarly here, centrifugal compressor, where the air being compressed centrifugally, right? And then you have the combustion chamber, and then the turbine stages, right? Then we want to go into the for the turbojet engine, right? Both engineer or the inventor Frank Whittle and von Ohain, okay, featured a centrifugal compressor and the early type of turbojet engine, but the modern one now using axial type, axial compressor and turbine, which consists of multiple row of rotating and stator. Stator is not moving. Okay. Upon the introduction of turbojet, fighter aircraft equipped with them achieve a top speed of at least 100 miles per hour, faster than competing piston-driven aircraft. Okay, so this is a turbojet with afterburner. So no, what happened is that instead of just a normal turbojet, you then introduce a fuel injector at the duct before it goes to the nozzle. You reburn the hot gases to increase the thrust. Activating afterburner, injecting extra fuel generates additional thrust. Okay, this is normally being used by fighter aircraft and for supersonic airliner such as Concorde, right? And it became evident that below Mach 2, turbojet exhibited significantly fuel inefficiency and produce excessive noise. So these disadvantages ultimately contributed to the decline of pure turbojet. You cannot just use a turbojet, and normally it's being succeeded by turbofan engine. So where it has high bypass. Okay. Uh, for the next one is turbofan. It is also a turbojet having a fan. So the majority of modern airliner, troop and cargo transport, as well as military aircraft, employ turbofan engine because of their high thrust and excellent fuel efficiency. So it has the same arrangement apart from having a fan at the front. Okay. So both the fan and fan turbine consist of multiple blade rows connected to extra shaft. Okay, normally being known as two-spool engine. One spool for the fan and one spool for the core, which involves some fan blade turning the shaft while others remain stationary. Right? So incoming air captured by the engine inlet, part of the air will bypass through the fan and proceed to the core compressor, then burn in the combustion chamber, and resulting hot air exhaust, which move through the core and the fan turbine before exiting nozzle, similar to a basic turbojet. Right, the remaining incoming air bypass the core, flowing around the engine, much like air through a propeller, and the air passing through the fans gains slightly increased velocity from the free stream. Consequently, a turbofan derives thrust from both the core and the fan. So engine bypass ratio of normally 1 to 2 are generally categorized as low bypass. And we have already bypass ratio of 10 and more in some cases. Okay, a typical picture, a schematic diagram of high bypass ratio, you can see um, 70%, 60 to 70%, or maybe 80% of the incoming air will be flowing through outside of the engine, not going through the core of the engine. So this is the core of the engine in the middle part. So the air being bypassed and then meets back um, the hot and the cold gases, they mix before it's being expelled through the nozzle. For low bypass, you can see that the less air being bypassed, maybe 40-50% will be bypassed, majority will go into the core of the engine, right? So since the fuel flow rate for the core experiences only a minor change with the addition of the fan, turbofan generates more thrust for nearly the same amount of fuel consumed by the core. It normally known as the high fuel efficient compared to the turboprop engine. Okay. Additionally, due to the enclosed design with multiple blades, the fan can operate efficiently at higher speed compared to a simple propeller. That's why it's much more preferable in terms of chosen in terms of turbofan compared to the basic propeller type of aircraft. Numerous contemporary fighter aircraft equipped with low bypass ratio turbofan featuring afterburner. So even it is not really a pure turbojet anymore. Fighter aircraft also include the turbofan type of configuration, right? For this kind of low bypass ratio afterburning turbofan, you have a very narrow bypass air coming through, and this is a typical for fighter or military aircraft. Next one is the turbo ramjet engine. Turbo ramjet engine is a hybrid engine between turbojet and ramjet. It is a combination of both. So the beauty of the this type of aircraft, this type of engine is that it can operate at low Mach number, and it can also operate at very high Mach number by um, operating the ramjet type of engine. Okay, so in these phases, it operates as a conventional turbojet where at low Mach number, but at a high Mach number, it will engage the ramjet type of engine, right? So the next one is turbo rocket engine. Turbo rocket engine is also known as air turbo rocket. It is a combination of turbojet and a rocket engine. It having a turbine-based combined cycle or TBCC, serve as an alternative to the turbo ramjet. So because it provide the rocket, it creates carry its own propellant. So over here, turbo rocket engine, where you have the variable air intake, after burning fuel burners, combustion chamber, and as well as oxygen supply. So to create the rocket propulsion, right? The turbo rocket engine also features a low pressure compressor powered by a multi-stage turbine. Normally, the temperature is around 3,500 degrees Celsius, which is very high. The fuel mix is then diluted with air from the compressor, and the excess fuel is burned in a conventional afterburning system, right? Despite being smaller and lighter than a turbo ramjet, turbo rocket exhibit higher fuel consumption. So more fuel being used in this turbo rocket engine. Okay, the last one is advanced ducted fan engine. Okay, for this type of engine, advanced ducted fan essentially resemble turbofan. It is part of the turbofan, but it is called advanced ducted fan, featuring large swept fan blades equipped with pitch control and reduction gearing, similar to prop fan. However, these fans are enclosed in ducts compared to prop fan. Prop fan is external. So for this advanced ducted fan, it is enclosed within the engine nozzle. So you have a typical range of um, bypass ratio of 15 to 1 and can go up to more than 25 to 1 ratio. A fundamental type exists. One incorporate a geared variable pitch single propeller fan, while the other utilizes counter rotating blades. So there are many research being done by Pratt and Whitney, MTU, and Fiat Avio to get the advanced ducted fan engine to be useful for the commercial type. Okay, last part of the presentation today, we will look at other engine, electric powered aircraft, and human powered aircraft. All right. So the third category and the final category classified as other type of engine. Right. We have electric aircraft, more and more research being done to use electric to power aircraft. So you can have a source of electricity from fuel cell, solar cell, power beaming, or even battery. So the advantages of electric aircraft, because you are having safety, reduced risk of mechanical failure, normally coming from volcanic ash. So that's why it is also having decreased noise, zero emission, and pollution. Right, there are still being researched, even though it's already started in 1970s. Until now, we cannot see a huge electric aircraft flying yet. Of course, the small aircraft, there are many, right? So it started in 1974, 1975. So there's a Solar Challenger. Okay, this is a NASA Pathfinder using solar. This is where the power source is from solar to generate electricity to propel the propeller. Okay. So this is another type of example of Sunseeker 2 solar airplane, right? And solar impulse airplane, which is also flying. This is a type of solar power aircraft. Okay. So let us just go into the last one, which is human powered aircraft. And human powered aircraft is known as a HPA, which is an aircraft that achieves, sustain, and control flight solely through human power, meaning that you yourself can design it and try to fly the aircraft. But you have to it is called human power, meaning that you have to propel the aircraft. So this is just a good example where this particular pilot he cycle inside the aircraft that there is a gear connected to the propeller, which have a very lightweight type of aircraft, then meaning that it can be propelled. Okay. So many history about human power aircraft. Maybe you want to have a read in terms of the historical background. Okay. To finish up our lecture, so basically, this lecture looks into the classification. Just an introduction to show to you that what are the available type of aircraft propulsion system. And we already categorized them into three main group. And the first one is external combustion engine, and then which include steam engine, Stirling engine, and nuclear engine. And then we have the second category, the internal combustion engine, which is further divided into shaft engine and reaction engine. And shaft engine are classified into intermittent and continuous combustion. And lastly, the chapter also explore other type of engine. Of course, we are not going into very detail. We just go into surface and just to introduce to you the type of propulsion, aircraft propulsion. Okay, so we look at electric power aircraft and human power aircraft. So basically, the classification serves as a foundation for understanding the diverse range of propulsion system which normally used in aviation, spanning from traditional combustion engine to innovative electric and powered solutions. So with that, right? So I hope you can go through again the notes that already been prepared for you. You can always ask question. You can email me. You can also ask Dr. An with regard to the topic that we have today.